Hello. There we go. Hi, SolarLune here. I'm an independent game developer and the creator of MasterPlan. Hold on. 1 second. All right, there we go. Okay, hello. Yes, hi. So I am SolarLune. I'm an independent game developer and musician and stuff like that. And I have been working on MasterPlan, which is a graphical visual novel. No, it's a visual like idea board. I've been working on it for about a couple of years now, and it's working pretty well. I've basically gone back to the drawing board and I'm rewriting the code basically from scratch, and it's going really well. This is actually resolved. This is not. This is something else. It's not master plan, but I'll show what I have here because otherwise, yeah. I'm sorry. Hold on. Okay, never mind. We're good. But yes, first of all, hello to everyone in chat. How's everything going? Stepo says, "What's up? How's it going?" Hello. But yes, this is Resolve, which is basically a collision detection and intersection detection library for Go. So it's useful for games, basically saying, where is something else in my space? Is it next to me? All that kind of stuff. And so here's a couple of little demos I've made. These aren't really new, but I've basically rewritten the code from scratch to be more, to have more use, to basically be a little bit better. And so I've been basically getting it back up to par, and it's working relatively perfectly. Not perfect, but it's working really well, I think. So this is a little platformer demo. I think I've shown this before, but basically you can run around, you can wall slide, you can walk up ramps, you can jump through as well as fall through platforms. And yeah, this is good, and this is, I think, a pretty solid little demo. And also you can like slide, as you can see, slide past jumps like Mario does, which is good because that's a nice way to handle platforming. But basically, the reason why I made this is because there's not really any collision or intersection detection libraries out there for Go, or even in general. A lot of frameworks seem to kind of miss this. I think Love2D has, I know, like, it has one, or it has a couple of frameworks, like community-made frameworks or libraries for collision detection or intersection detection. But I wanted to write one for Go because I like Go. And so yeah, this is a little line of sight test where we can see where's the closest wall, essentially, to the player. So this is useful if you, for example, have a stealth game. Let's say the player is where the mouse is, then the enemy can see where the enemy could see conceivably. This I'm probably just going to remove. This is a simple collision detection, intersection detection, so you can see, for example, where a circle that you're controlling is intersecting with other shapes and how far to move it to get it out of the intersection. It's not perfect, but it works okay. And this is the same thing, but with a convex polygon, a rectangle, a square in this case. Again, not perfect, but it works okay. So it just, you can press space also to get it basically out of whatever it's colliding in. And so that's it. That's resolved. So basically the plan is to release the current version, which is largely better than the previous version of Resolve, and let people make games with it. Now MasterPlan. Oh, MasterPlan. All the music. Hold on. Where's my tunes at? I wonder if I could play other music. Nah, I don't wanna risk it. I can't risk it. This is not what I usually play. Actually, hold on, my audio's not coming through. There we go. Okay. All right, we'll keep it low. Yeah. So this is MasterPlan. MasterPlan is a graphical idea board, like I mentioned before. You can place stuff on it. You can like make maps, for example, for video games. Like if you're making oh, Sweetie Bun says hi. Finally got here early. Hello. Welcome to the stream. Welcome to the chat. But yeah, basically, like you can make, for example, maps for things like a Metroid-like or an RPG where you need to plan out, where things are in location in relation to each other. You have a timer that you can use to time things. For right now, it's just a stopwatch. You have a checkbox task kind of card where you can be like, okay, this is something I need to do. Placing them together will number them like so, which is cool. You can type freely and have cards expand as necessary as you type. That's cool. You can also resize them manually. And you can load images and sounds. You can also drag and drop them. Something I added recently was the ability to draw lines. So if you, for now, you just hold Z and you can draw lines between stuff. So for example, you can be like, okay, this task needs to be linked to this card, this note, for example. It's not drawing in the correct order yet. I have to figure out exactly what order to draw things in because it has to draw underneath cards, but it has to be on top of maps specifically. But the upside of this is basically you have the ability to draw lines pretty easily. So for example, if we go to this folder, make it smaller. If we go to this folder, we can drag and drop onto MasterPlan. It'll load the image, and then we can size it down to make this little character. Put this character somewhere on a map, for example. Copy and paste it somewhere, and then we can draw a line between them like that. And that's useful because if you're trying to plan out where are NPCs in a game world, you can easily do this and be like, okay, this would be good if they were here, or whatever. So that's cool. This needs to be looped. The music. Yeah, so that's the upside. That's the cool thing. I wish the line was a little more anti-alias, just a little jank. Well, not jank. It's just pixely. I would like it if it was smoother. But this is fine for now. It's fine. And this is an improvement, I believe, over the previous version of MasterPlan where you had to create a line task type. Now any object can basically have a line created to it, which is good. Yeah, so and you can have as many lines as you want going between cards. You don't have to have only one or whatever, or anything like that. So that's cool. Yeah, that's cool. I guess one thing I would like to do is be able to, for example, while holding the line button, right click to slash a line and cut it. That's not very hard to implement, but that's not very hard to implement. Let me maybe I should just do it. Well, I think that would be easier done once resolve is made up better. Because if resolve is made better, like if once I get resolve working, then I can make it so that it just basically searches through the lines on the map, lines on the map, creates a resolve line, and then checks to see if you're cutting it. Yeah, so I'll do that, I guess, later, where you can right click, for example, or slash a line to cut it. I think that's a cool mechanic. But for now, this is working well. Alright, so the next thing we're going to do is something else. We're going to keep working on this. Also, the link, let me see here. I believe the link to the... It is not, hold on. So MasterPlan source is available. The link is now, I'll put it in the chat as well. But the link to the repository for MasterPlan is there. It is in the, or this specific version of MasterPlan is in the SDL rework branch. So if you're interested in looking at the code or trying it out, you can do so there. All right, so this should be fixed. Yeah, this needs to be fixed at some point. Add linking. That's what I did. Split shortcut. Use this when editing text boxes to split a note or checkbox into two between the cursor. That would be cool. Downloading and loading images might not be multi-threaded. Okay. So there's a couple things I wanted to implement, but this is kind of like the number one, I think, is card movement. So we'll see about that today. I gotta get that working at some point. I just have to go ahead and commit this, and then we'll be good to go. Okay. Page that update links is called to update links between cards on a single page. That's unnecessary information. Let's see. Okay, so we're pretty good here. Validity. Do I use this? I do use this. Okay. Where's the card that? I guess I need to do this. Let's see. I could just do this actually. This is unfortunately kind of complicated, kind of a complicated solution to get this all working correctly, but at the same time, yeah, got crushed. Nil pointer. So maybe we don't want to do this. Maybe we don't want to unlink the card after deletion, because if you delete a card, then it unlinks. Let's not do that for now. When we serialize, though, we only want to link serialize it if link dots, because the star is always going to be the card generally. So that in dot valid. Oops. There we go. Let's try that. Lucretius, hello. How's it going? The Lune is back at it. Yep, back at it. Back at it again in the Krispy Kreme. So okay. This is jank, but okay, right. So there's like extra undo steps here. Is it because of this change? Maybe it's because of this change. It's not perfect. I might just have to commit it like this and fix this later. But it is, you know, like it's not always undoing or redoing. Don Duval says, are you using any design pattern to make the undo redo system easier, like the command pattern? I'm not sure if what quite you mean by a command pattern. If you mean like, am I writing commands, like is undoing and redoing, basically undoing and redoing commands that create the current state of the card? No, because that would require rewriting like a lot of how MasterPlan works. It just felt easier to just serialize the current state of the card, and then undo and redo is just moving back and forth, you know, to the next or previous state. So if you have a card here, you know, this is an undo step, but then when you move it here, this is another undo step. So we're not recording the movement, we're recording the card was here and it said new checkbox, and now we're recording the card is here and says new checkbox. And if we change it, now we're recording the card is here and says change. You can see this if we go to undo and uncomment this block, which is basically my undo debug. You can see, excuse me, you can see here is the first state. This is the card, the serialized card, with the card pointer to the card. This is the JSON that basically composes the card, the serialized data. This is whether it was created this frame, and this is whether it was deleted this frame. And if we move it, now there's another frame, another undo frame, where it's at another position, and the creation flag is not set anymore. So when we undo, we go back to this frame, and when we undo again, we delete it because this boolean is true. And then when we redo, we check to see if this boolean is true, and if so, we restore the card. And that's it. That's how the undo system works. it works really well, except for when I add something to it. Then it tends to be like it doesn't work quite as well as it should, which might be indicative of it not working really well. I don't know, but at the same time, it's hard to kick it out, you know, to just be like, I have to destroy the entire system when it's like it's relatively rare that it doesn't work right. And I think maps worked well, so I think it's not that it doesn't work well, it's that certain things like this don't work well because of how I'm kind of trying to set up, how I'm trying to get everything to work. So I guess there's a couple things I can do here. Hold on. Let me take a look at this. Well, actually, let me do it. Can I make a simpler example? Don Duval says the command pattern is different. Yeah, a queue of commands that contains the specific data about the command in the previous state. The queue can then be traversed. Yeah, that's the right way to do it, or at least that's the idea I had was like, okay, that's probably the right way to do it. But I didn't want to have to implement an entirely additional system just for undos and redos. I was like, that's okay, but it felt like it would be kind of too much. I thought, well, if I do it this way by serializing the data and then just basically deserializing it whenever you undo or redo, that kind of works a little better. It doesn't work better, but it's a little more efficient in terms of space or code space, because I don't have to implement an entire, like, you know, system of commands that you can use to basically modify modify a card or a task. Like, if I had a terminal within MasterPlan where it's like, or some sort of a method to like use MasterPlan from a command prompt where you don't have a visualization, then maybe I would be like, okay, it makes sense to kind of implement that, because you could, you know, we can use that for MasterPlan normally, and then we can also use it for the undo and redo. Usually you implement it at the input layer, so the underlying system doesn't change at all. Yeah. Wait. So the command pattern works on top of the input layer, so that everything is working the way it does. Oh, I see what you mean. So basically, it's another method of input. Okay, yeah, that does seem like it would be a better method. Yeah, overall, yeah. Like I definitely would go with command pattern if I could. I just don't feel like. I feel like this is a little better because you're saving code space by basically serializing the data in the same method that you would serialize it when you go to save the card information. So this only basically is using the serialize function for the cards for saving, you know, to a file. It's the same principle and code to save it to the undo state. And then we're just moving back and forth and creating the state when we need to, creating the undo state. Yeah, I gotta fix this drawing order. We'll do that next. But I can't reproduce this problem. What is this? What is this? 2? Okay. So the links aren't in the same order. Ho ho, why are the links not in the same order? Why would the links not be in the same order? How did that happen? Let me make it smaller, hold on. How are the links not in the same order? This is for 2. 2012 1220. Yeah, they're not in the same order. 1220. How did it change here? Eboat Right says, "Hello, SolarLune. How are you doing?" Hi, I'm fine. I'm tired, but I'm okay. Thank you very much for asking. I'm working. Working okay. Don Duval says, I assume you're able to reuse the serialized functionality for the save system too? Yeah, it's the same functionality. So that's the upside, is basically we don't have to have an entire command, system where we have like strings or functions that correlate to, movement of cards and, changing card properties and all that stuff. Instead, we just have, the code to serialize cards for the save system. We can just reuse that and deserialize the code for deserializing. We can just reuse that for undos and redos. So the core problem, at least I'm seeing here, is that these basically, when we go to see, is there a previous state? Does the previous state have, information on this card? We basically see if, well, let me just show you. When we capture an undo state, we say, we check to see if the previous state is the same. And if so, we don't really want to do that, right? We don't really want to capture an additional state if the previous state is the same. So the problem here is that these states are not the same because the link order is different, which is generally bad because, I believe that's causing this problem where we have an additional undo state that doesn't need to exist because nothing actually changed. It's simply the link order that changed. So when we serialize the links, I'm not sure why. Oh, okay. So when we serialize the links, we're stepping through it correctly. It is a slice, so it is ordered. But when we deserialize it, we're always unlinking all of the cards, which is really what we don't want to do. I don't think we want to unlink the cards unless it's necessary. eBoat Right says, I finished my game Miniland I was working on last stream and it's released on itch. Oh, cool. I also released an update yesterday that added a lot of stuff. That's great. Great to hear. Congratulations. That's exactly the kind of energy people should have, is one of completion, support of their projects and products, and working on stuff. I'll give you some claps. YouTube doesn't let me post links. Let me see. Miniland. I gotta take a look at it. Hold on. Pure Java, dude. That's crazy. Yo, okay, this is sick. I'm gonna go ahead and put it in the chat. There we go. Yeah. So yeah, this is cool. Okay, so congratulations on completing your game. Definitely want to encourage that. And I'm impressed that it's pure Java. That it's not like you're not using libgdx or LWJGL. As far as I remember, if that was you, I believe it was you. That's great, dude. That you're able to like get control of take control of your workflow and decide, what do you need and what can you do you not need? What can you? What's the bare minimum? And that allows you to really control your space, control your dev space. When you can decide, this is what I want, this is what I need. I don't need that. I want this. Having that control, I think, is really important as you get further along in game development. I think or at least having that control is really important for people for whom it's really important. If you can get by with Unity or Godot or whatever, that do it. That's fine. If you can get by with Ebiton or Love 2D or something like that, do it. But if you're like, I can't rock with any of these, all right, then do it from scratch. Couldn't get LWJGL up and running on my Mac, so I just used Java's built-in AWG. That's crazy, dude. I thought LWJGL, I thought it was well supported. I'm not sure if it works. I imagine it works on the new Mac M1. But anyway. Okay, so the problem here, is that we're unlinking all of the cards, all of the links, all of the time, which is not what we want to do. Let me see. We really want to only do it if the link, old Mac from 2012 to 2013. Oh, okay. So we only want to unlink this if the card links, the proposed links are different, I guess you could say. So we'll do that. We'll say unlink all. Actually, let's see. We'll do it like this. Okay, so now we want to see basically actually this should be a map. I guess it should be a map. Well, we want to see if these are different. If the link count, or if the links that we're basically, if the links we have from card A to card B or card, A to potential cards is different from the current links, and if so, we want to deserialize and we want to go through that. Darkcoin says, "Hey, hi, can you tell which distro you're using?" Sure, this is Manjaro. It's a really great distribution, highly recommended. It's very good, very clean. Yeah, I like it a lot. Also, I'm using Blur My Shell as an extension, which is cool, but you can't really see it because the top of this background is just gray. But on a more complicated background, you can see it actually does blur it, which is it looks nice. Have you tried Linux Mint? Says Lucretius. I have. I don't generally like it. I like it as a distribution, but the visuals are kind of like, like it looks kind of like old. It just looks. It doesn't look clean and sleek. It looks kind of like a 19. It looks kind of old, like a kind of like traditionalist, version of Linux. I think it uses GNOME, so it should be possible to reskin it and kind of like, change the way it looks rather. But I like Manjaro. I think that's, you get the, but yeah, also it's not bleeding edge. It's not, or rather a rolling distribution, compared to like Manjaro or Solus or something like that. And I like rolling distributions because even though they might not be quite as stable, they're still really stable, and you get nice up-to-date versions of everything. So it's like, I would recommend Linux Mint maybe to someone who's like, new to Linux, or I probably would recommend Pop! OS first. But yeah, Manjaro is like, if you're familiar with Linux, or you just like Linux, or if you don't mind going into something that's a little unusual, Manjaro is like, it's pretty good. Can do it for a very long time. It needs a bit more setup. Yeah, Manjaro doesn't really require that much setup. I think Arch does in comparison, but I think there's Antergos. I'm not sure how to pronounce it, but that is a good one, I suppose. Supposedly, Absolt says hello. Yo, how's it going? Welcome to the stream. Manjaro, yeah, Manjaro's good, in my opinion. Let me get some different music before I forget. Let's go with this. All right, so yeah, I'm trying to think of if there's another way to do this. So we want to compare if they're different. So for link end, if link end dot, well, actually we would need to know. It would have to be okay. We could do it like this. So then we say for like we don't care about the order. We care about the existence. So I guess we could try sorting them. And then comparing them. Because regardless of whether regardless of like the numbers, the significance of the numbers, if we sort them and compare them, if they are not the same, then we know that something's different and that we need to deserialize, right? So like if you have this, which is 2012, which is basically from task 2 to task 0, and then from task what? Oh yeah, from task 2 to task 0, and then from task 1 to task 2. And this one's task 1 to task 2 and task 2 to task 0. If we sort it the same, it would be 0, 1, 2, 2. 0, 1, 2, 2. So it's not from 0 to 1, but it doesn't really matter because they're gonna sort the same way. So I think that we can do it that way, and then just say if the length is different, or we loop through and they don't have the same values in each, then we know that it's different. Okay. So if links card same equals, we're gonna assume that same, they're not the same, and then we'll say for L and range links, I guess actually for I and range links, if links I is not equal to car.link, actually I is all right. I guess we'll assume it's true. Same equals false, we break out. Okay, and then we say if same, not same, and we do this. Okay. Alright, so this should kind of do it. Okay. So I'm going to sort both of these. Alright, so that should kind of do it. Let's see. It is not working. Let's see. 0, 1, 2. Alright, and then from here we link it to 1. 0 to 1, and then from 1 we link it to 2, 0, 1, and 1 to 2. 1 to 2 to 0. Alright, that's correct. I'm not sure why undo is not working. Let's see. Sorted links. I guess this would be false. Well, that's probably correct. Let's see. I messed it up. Crunch. Let's see. Index out of range 2 with length 2. Oh, oops. This is supposed to be sorted. And this is supposed to be existing. Let's see. Talking about editors. So we're forced to use VS. Visual Studio. Okay. What is... Yeah, what was that? Hold on. One, two, 3, 4, 5, 6. Why is it... Okay. We'll do this. We will say if it exists. Okay, this is what I need to do. If it doesn't exist, then we need to unlink them. All right. Eboat Rice says, are you working on the connection lines? Yep, that's exactly what I'm working on. Sorted links I. Index out of range 2 with length 2. If okay, then same is false. Else. Okay, that's better. Okay, that's better. Yo, it's still broken. Let's see. So this 1220 and this 2012 are the same. This just created an additional undo step. But we're sorting the two. If sorted links I is not equal to existing links I, and whether they're the same is false. This should be bigger. Whether they're the same is false. Okay. Hold on. Six, 3, 4, 3, links 3, 4, false, 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 false. These are the same. I'm not sure. Oh, hello. How could that be happening? When we serialize, do we not lock the position? Apparently not. Okay. Wait. When do we call create undo state? We really don't, huh? We don't call lock position. Only when deserializing. Okay. Modal editors. I've never tried a modal editor before. Alright, well, before we serialize, I guess we can lock the position. I guess we're good to try that. Let me think. When we want to not lock the position, I don't know. Like, it's still happening. This is still happening. Let's see. Sort. Zero one one two 0112, yeah. Oh, I'm doing this wrong already. I am doing this wrong. I need to probably change it when we go to serialize, or yeah. Here's what we're gonna do. I don't care. I don't care. I completely was incorrect in my theory of why this was happening. I completely forgot something. Anyway, we're just gonna go ahead and go with this. Right around here, I think. Unlink the cards. Let's see. We can unlink them here, I think. That's fine. Okay. We will just go back and try this again, so we can see exactly how this is working. This isn't perfect, but it's good enough. Yeah, let's just get this going. Oh, undo. We don't need that anymore. What did I change? Ah, okay. See a crash when we're sampling empty space and clicking and changing the pattern. Some keys. Validity, okay. Draw lines, okay. Draw lines, draw content, post draw. Oh wait, didn't I have this? Yeah, this was... Oh wait, yeah, no, I think this is right, actually, that it's not there. Because if a card isn't valid, we still want to maintain our link to it, I think. No, we only want to maintain the link when serializing if the card is valid. Is that right? Update links. So I see. So when we go to card, we go to deserialize. And we do this. We only want to do this if the card link is valid, right? No, okay. No, wait, hold on. I gotta think about this some more, because the problem I'm struggling with right now is basically if we have, let's say, card A connected to card B, you delete card B, card A should no longer have card B as a link. Otherwise, you could end up with a card that has a million links because it's connected to a million cards that were deleted over the course of a period of time. So I guess we want to deserialization is fine. Serialize is fine because we want to serialize only the cards that exist. So then when we go to page to deserialize, we basically want to just see if the card exists, I guess. Try that. Alright, that seems fine. We're gonna go with that. Alright. And now, an hour in, we can finally start doing the things that we actually set out to do. Let's see. Alright, so card movement. That's the next step. We have the ability to set up stacks of cards. It would be nice to be able to move cards. Actually, before we even do that, I'd like to be able to add a card to a stack in an appreciable way, because that has yet to be added. So I want to be able to do something like bop and basically have this card be inserted into the stack. So we call update stacks. So we call update on the stack. Okay, so update stacks and then post update. Okay. So this is where I was trying to do something like this. That actually works pretty well. But yeah, it's definitely not perfect. Okay. So here's, I guess our first step is to create a clean, like, test bed. Something like this. Okay. We will call this 1, 2, 3, 4, 5, 6, 7, and 8. This will be our numbering or stack movement test. Okay. And then we'll say this is like the interjector. Alright. Actually, let me fix another thing before I forget. Where's the global? Okay, here's the save projects. We can just go ahead and be like globals key bindings dot, or key bindings is a, okay, that get or shortcuts. KB save project dot consume keys. Undo, nope. Copy, paste. I guess actually that can be consumed. Paste cards will not be consumed. Select all. Delete cards can be, no. New card. No. There we go. Yeah, we're pretty good. Return to origin, consume. Alright, we should be good. Now, the next thing we need to do is get this working. So currently this works okay. What I'd like to do is both have it like that, where if you move a I see, okay. So once we do this, hold on. Once we, where's, actually it's stack, okay. Once we do this step, we can close the others. Oops. Close to the right. Once we do this step, we need to call we need to update the stacks later, but then also we need to have it so that when you move a card out, the rest of the cards move up. So we'll do this here. Well, actually, let's do this. We'll do this later. We need to first. We need to get it working so that when you insert a card, it Absol says what happens with two interjectors. We'll see in a couple seconds. I want to build it up piece by piece. So for now, this should work. It does. It doesn't work like this. It only works, looks like, if the card is directly over. Stack above, stack dot tail. Alright, let's see. If stack dot card dot selected, then print out stack dot above dot stack dot tail. Because I need to see where is this object being placed in the stack. Eboat right says the stacking system looks really complex. It's not too complex. It's basically just kind of like a vertical. It's just a slice or a sequence of cards organized basically by vertical position in the stack. If a card Oh, yeah. And stack that above is not cool. If a card is placed directly below or directly below or above another card, then it becomes a stack, or rather, a stack is created. It's a little complicated, I think, to determine like what stack it belongs to. I guess they all have their own stack. Yeah, so a stack, like they don't belong to a single stack. It's just each card has its own stack that determines like what's the card above me, what's the card below me. That's kind of it. Okay, that works fine. That works fine. This does not work. Stack above is not equal to stack that previous above. Stack that. Oh, I see. Because when we do this, the card below 5 is now interjector, when 6 is also below 5. So what we want to do is really do something like this, and then say basically if card is not equal to stack.card, then we move it down. I think that might be what we want to do. Let's see if it works. Okay, well, it just messed up everything. Let's see why that might be the case. 6, 7, 8. Okay. I have an idea of why that might be the case, but for now, let's just see if. Yeah, no, it's not moving 6 down. But it moved 5 down there. Excuse me. Alright. I'm not sure if this will help. Let's see. That definitely works. The issue here is it's interesting that it's not solving the core problem that we're having. The change isn't solving the core problem that we're having. Let's see. Stack that tail. Can we do something like this? I don't know if this will work in the context of a list. I don't. Yeah, it doesn't work. Okay, better. Let's see. For now, can we just say like to string or to? You know what? Let's just do it like this. Let's print out the rectangle and the contents. That might be fine. That doesn't help. Let's go with the rectangle. Oops. Okay. So if stack above is not equal to nil, and stack above is not equal to stack previous, previous above is entering the stack, which is true, but we only want to move if we're basically sitting on a card. I guess that's really what it is. So maybe we could kind of work this. Above, if cards above. Yeah, we could rework this a couple ways. Above and below can both be slices, I think. I think that could work. I mean, actually, just yeah. So I think basically, rather than picking out one card from the cards above, we can just basically be like, here's the cards above. And then similarly, here's the cards below. So we're not picking out one single card, which is useful. And then we could also have like on to be a list of cards that we're sitting on, previous on. That's really the most important one, honestly. Top of the stack. Head, okay, head, tail, top. Rest above. You know what? Let's go back, because I'm thinking in a stack, ideally there's just one card. Like, you know, like in a stack, you're just in with, you know, A, B, C, D, E, or A, B, C, D, E. And if you place a card in there, there still should only be one card in the stack. Like in each slot in the stack, there shouldn't be. It doesn't make sense to make a stack that's composed of multiple cards in a single row, where it's like A, B, C, D, E, F, G, H, I, like that. I don't really see the point of that. In the context of this program. Like, there's, you know, it could be useful maybe in general, but I don't think that's useful for, like, we can limit it, and I think we can get away with that. So we'll add a variable, add a property specifically to see where we're kind of in a stack or in a card. That's going to be grid.cards, grid. Alright, well, I guess I don't have a function for this. We'll just say cards interact. For section of cards, card is not a C, cards equals a pin, cards interact. So I guess this could actually just be like, oh, that works. Yeah, this is fine. Okay. Well, I guess we can just do like this. No, we can't. Okay, never mind. We're good. All right. So this is going to be grid.cards interact. Our cards at. Oh my gosh. Hold on. stack.card. All right, so now we can say stack.on is equal to cards at 0, and then stack.prev_on is equal to stack.on. All right, so this should kind of get us where we're going. So now instead of this, actually this works well. We're just gonna say instead of this, or in addition rather, if stack.on is not equal to nil, on is not equal to this might work instead. This is exploratory coding, everybody. What am I doing now? Basically the same thing. I'm just trying to get it so that if you set a card on another card, it moves down like that. Okay, crash. That's not good. But maybe we're getting there. Let's see. Right now I'm just trying to see, is it even acting kind of correctly? So I put it here. All right, it kind of works. Let's see. Stand up on. I think the issue here is that this is like interjectors stack update is working fine, but then 2, its stack update works in addition because it's now in 3's place. How do we resolve this? A Big Red G says, "Yo, hello, welcome to the stream. How's everybody doing today? Or how are you rather doing today?" So the interjector. What if we just do this? Oh, why didn't I just do this? There we go. I feel like I'm there. Don't do that. Just say this card stack.on.red.y plus equal stack. Ow. Card. Let's try this. Maybe we can simplify this to kind of understand the problem a little bit better. So where can I paste? It'd be nice if they all resized. Okay, so if we put this here, C moves down, but we also move down. Why is that the case? And after moving, it's like we can't move it anymore. Oh, that's why. Okay. So what we want to do So that's indicative of a problem, I guess you could say. What we want to do is go to card. Something I forgot is this. We need to call this function. So we're going to make a function specifically for moving. Specifically for moving a card, where we basically say how far we want to move it. Card.rect.x plus equal dx dy. We lock the position, and then we call put to reposition the card. Okay, so that should help, because now when we go to stack, we can just call stack.on.move 0 and then stack.card.rect.x or h. Okay, we're getting there. It seems like I'm struggling, but I think I'm getting there. Okay, so now when we move the interjector here, C should move down. The interjector also moves down, probably because why does this not work? That's weird. Works for B, works for A, but once we that's exactly what we wanted to do. That. Now, in order for that to be consistent, what we want, the problem here is basically eboat right is gonna head out. Okay, great stream. Thank you very much for stopping by. The core issue here is that basically we want to do this specifically only on the card we're moving. We don't want to do this on anything else. So if card A gets dragged onto card B moves down, or card A pushes card B down, but that's it. We don't want card B to basically say, well, you're on me too, so I'm going to pull you down. That's basically what's happening. And I'm not sure how we can kind of avoid that. Okay, maybe I have to rethink how I approach this problem. Because fundamentally, knowing which card is above and below is important for numbering, so that's important. But in addition, in order for us to know when a card is dragged onto another card, maybe we should make a message or do something specifically for that situation where a card is being dragged or moved into another card, so that we don't do this on the stack level where basically every card, kind of operates on this level. Instead, we have something special for a card being moved onto another card. That seems better. It seems like a better solution. So we will get rid of this, and we will get rid of these. Alright, so now it's drastically simpler. And this is specifically for just numbering. Update. Okay. Now, after this, we want to go ahead and say stop dragging. Alright, so this is where we basically drop a card. So we want to see if there's a card that we are dragging onto, and if so, move it down. We will put that in the stack, because that's specifically to do with stacking. So we say if card dot, you know what, let's just do it like this. Card dot stack dot stop dragging. Or I guess we could just say moved, on moved. Okay, so for now we're just gonna say like moved. We're just gonna I'm just trying to make sure it works first before we go any further. So we have a stack here. Moved, 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 moved. Okay. So now on is going to be or card on is going to be stack.card, or rather, yeah, stack.card.grid. I guess page.grid dot cards at. Okay. All right, let's see if we get a result here. Because there's no cards anywhere. If we move it here, there's now 2 cards. Why is it select? There shouldn't be multiple cards in the list. Excuse me. Oh, excuse me. Pardon me. Alright, well this is a good thing about working on stuff like this, is that you get to see where bugs arise and get to kind of fix them. Zero 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 one. Wait. How's it finding so many cards here? So select XY width and height. Select line position XY, X plus width, height. TJK says, is this pure SDL or is OpenGL rendering being used? It's SDL only. I think the backend is at OpenGL, but it's just SDL. Plain SDL. I've added... Oh, yeah. No. Yeah, that's right. Okay. Wait, key value pair. I thought this isn't this the thing for exists? Yeah, that's right. Because you're putting the key in. Okay, so it's not key value because it's not for loop. Okay, we're good. All right, then I don't know why we're getting stuff multiple times. Let's see. I think we're getting stuff multiple times. Yeah, like here, moved is being added twice. Or there's 2 cards here. Well, it's 1 card twice. So why is cards at cards? Okay, where are cards? Pin card C. If the card is not equal to C. C for FM print line. 0, 1, 2, 3. All right, these two are the same, and these two are the same. So 0, 1 is the same, and then 2 and 3 are the same. Or no. 0 and 3, 0 and 2 are the same, and then 1 and 3 are the same. Now why? When we go to cards, I don't think this is going to tell me very much, but let's see. At some point, if added, not added, cards equals append, cards, cell.cards. Oh, no. Yeah, okay. It's not. This is wrong. There we go. That's the issue. Okay, we're good. We figured it out. There we go. Now moved is just 1. Okay, we're good. We're good. It was my own. I was hoisted by my own petard. If I may wax poetic. All right. So anyway, we're getting there. We're getting there. This is, let's see. Okay. There we go. Okay. So you can see we're moved on this card, this object, ending in C0. We're moving on this object ending in 0, 0, and then back to C0. Okay. So it's just that one. And then when we move into blank space, we have blank space. This is fantastic. All right, so now here's what we're gonna do. We're gonna say card on dot 0, I guess, dot move. Well, I guess if card on is greater than 0. For I guess we can say for C in range card on. I guess then we don't need the length. We can just say for C in range card on C dot move 0. Really, we just want to move it down by the size of the rectangle, so we're moving there. And then we basically want to say for rest in range C dot stack dot tail rest dot move 0 stack card rect h, and then also we want to update the stacks. All right, this should get us closer. All right, it's not perfect, but it's getting there. That's beautiful. Moving it to 7 and 8 works really well. Yeah, that works really well. I'm not sure why this is moving after I move interjector off. So we're updating the stacks. Oh, I see. Because if we move both, no. That works really well, but it's not perfect. On moved. Card on. Okay, we will, wait, when do we call, hold on, when we call on moved, let's move this here, that way we can know when something is being dragged, and basically say if c.dragging, then we just continue. We don't even mess with it if the card is being moved. That's an idea. It's a little bit, seems like a little bit of a hack, but it might work pretty okay. This is not okay. Just for clarification. Why does it move this one too? Like I'm not. Why is it moving 6? Oh. Okay, hold on. We gotta lock the position first. Okay. This is a very specific like setup, but once it's working, it'll be so worth it, I think. All right, there. There. Okay, we're good. We're good. All right, we're good. We're good. All right. Ladies and gentlemen, it's not working. Ladies and gentlemen, it's not working. But that's okay. Like, that's good. That's beautiful. This, beautiful. That, beautiful. This, why does 3 move? Why did 3 move there? It was like this, and then we moved interjector here. 3 moved. That's correct. It's like in a certain order. Beautiful. Oops. Like, why does it move the interjector? Like, once it works, it's gonna be so sick. Why did it move the interjector? Let's see. Is it because it's in the tail? It's because it's in the tail. But we're dragging interjector. Oh, but yeah, it's because it's in the tail. Okay, so basically, dragging. Continue. This isn't ideal, but let's see if this works. All right. Alright, that's definitely better. Yeah, that's definitely better. That's definitely way better. I almost forgot. Let's try one last thing before I move on. What if the interjector is bigger? Not perfect at all. Let's try this again. So let's say we put it here. So 5 moves down correctly. 6 moves down. 6, 7, and 8 move down way too much. Why? So the card we're dragging it on moves down. Oh, because we're dragging it on multiple cards. Oh, yeah, that makes sense. Okay. So we want to probably just grab the top card. So we will just say if length card on is equal to 0, then we're just going to return. Excuse me. Or rather, I guess the right way to do this is just if length card on is greater than 0, then let's just do it like this. All right. Oh my gosh. All right. All right, this is better. This is better. Should be better. So the card movement seems to only take into account the thickness of the card you're moving, right? For every subsequent card, the movement has to be done based on their respective thickness. Is my understanding correct on that? That shouldn't. Your understanding is, I believe, slightly off. Like once, because they all need to move. Or maybe you're right. They all need to move according to the thickness of the moving card, the interjecting card. It doesn't really matter. Yeah, it doesn't really matter. Like once we move the first card, we move the tail according to the same amount of distance, because we're assuming that they're all positioned correctly to begin with. Yeah. All right, so it's not perfect. This works well, but once we move this here, 7 and 8 are also moving down. Why would they also move down? It's because the card is included in the tail. So if the card is in the tail, then we're moving it. So that means we can move. This is going to be a little tough. So here's the problem. Let's go back and kind of work this. So we move a card into a stack. It moves the rest of the stack down. No problem. We move that card into somewhere else in the stack. It moves the rest of that stack down, but it also moves these cards down, because these cards, or the interjecting card, is part of the stack. So it was at between 6 and 7. So once we move it here, it's like, all right, I'll move 4, 5, and 6, and 7 and 8 down, when really it shouldn't move down 7 and 8. So the amount it moves down is basically, maybe the right way to do this is to make a theoretical stack and then position the cards according to that. That might be the right play here, because moving cards like this is a little finicky. It seems like the right way to do it is to basically say which is the card at the front of the stack, which in this case is 1, and then create a list, sorted vertically, of the cards as they should be positioned, and then just position them based on that. So that when you, because I was planning to additionally make it so that when you move a card out of the stack, it moves the rest of the stack up. But it's probably better to just create a ideal stack and then position them according to the top card moving down, so that when you move a card in or move a card out, you don't really have to do anything. It will automatically position the cards as necessary. That's probably the right thing to do. That's probably the right thing to do. So we move a card into another card. It says I'm part of the stack. I will now go from the top and create a new stack, like create a new sequence of cards, and then position them vertically, so that if you move a card out, I think that's the right play. The problem that I had was basically, this is kind of what I was trying to do initially, and that didn't work, which is essentially, or it was difficult. Essentially, this would be best done, or this would work really well, if I could somehow get a situation where we have a central object for a stack of cards. That's the problem, is that I couldn't get a central object for I was kind of having trouble getting a central object for a stack of cards that basically kind of handles the positioning of those cards, the order of those cards. That would be great if you could just be like, oh, I moved up 3 spaces, so just move me up 3 spaces, or I moved down 3 spaces, so like rearrange the other cards to match. It'd be great if I could do that, but the problem is, how do we know which stack to join? Because if we have, for example, 1 is the creator of the stack, and all the other cards are in 1 stack, when we move 1 away, now 2 is the head of the stack. I guess I should have just fixed that. That's probably the right way to do this. This is not the right way to do this. I think that that's really the problem I'm running into. Alright, What would a man be if not a pile of regret? We will rewrite this from scratch. So the core concept of a stack is it's got honestly, I guess it has an order. It has a stack of cards. Yeah, that's about it. So here's what we're gonna do. And I guess this is, yeah, stack, update stack, stacks, yeah. We're not going to do update stacks. I guess actually we can do update. Well, I don't, yeah, let's figure that out later. For now, the idea is when we drag a card, we need to know which stack it needs to belong to. So basically, is a card above, it is basically a card in this area, anywhere around the card. Like if we were to drag this card into this position, we need to test this area to, well, I guess actually just this area, to see where any neighbors could be, either above, below, or inside. And that basically determines, like, oh yeah, you know, I've been dragged into a stack. Okay, so that's the first thing. So when we stop dragging, lock position, I guess actually we could just call it on lock position. Move is definitely still useful. Oh, lock position calls put. Okay, so then we don't need to call put. Alright, lock position. Stop dragging calls lock position. So it all comes back to lock position. Okay. And update stacks. Okay. So here's where we see what stack a card belongs to. So maybe the right thing to do, this is where I kind of ran into issues, because I was like, well, you know, you gotta have, like, each card has its own stack, etc., etc. Maybe the right thing to do is to basically say, if there is a stack, yeah, that's what I think what we need to do. All right, I think I'm getting there. I'm getting there. Lou says, Lou Peabody says, just wanted to pose the option of modeling the cards as nodes in a doubly linked list. Each card has a reference to its parent and child lists, and the next previous card in the cards in the respective sequences. That's kind of what I did, but the problem is it's overly complicated because you end up having to move cards manually. When, like, it was working okay, but when you moved a card into the stack, you have to move every card underneath that down, and when you move it out, you have to move every card underneath, you know, the rest of the cards underneath that up, which is fine, except for when you, like, move cards, because of the timing of movement and when the lists are updated, it would kind of cause problems. It feels like the easier way to do it, or the right way to do it, if I'm correct. Let me break out a spread here. It seems like the easier way to do it, or the right way, or not the right way, a way to do it, that might be easier for me to comprehend, might be to simply do something like this. Whoops. Do something like this, where we have, you know, a card here, right? And if we drag a card into this position, you know, anywhere like this, then it will check this area to see if it's in a list. And it's like, okay, there's a, you know, I got dragged into this position, there's a card above me here. There also could be a card below me here. And if so, I would join their stack. Once it joins the stack, it updates, it calls the page, or, you know, this could be called globally for each stack, but it basically can say, like, okay, it's time to update the stack. Let's grab the topmost card, which is going to be this one, and then just put order the cards according to their vertical positions, and then move them as necessary. So in other words, when you join a stack, you're putting yourself into the stack, and so you don't really have to worry about manually positioning or anything like that, or moving the rest of the stack. The stack will handle movement. So all you have to do is be like, I'm second, or I'm fourth, or I'm first, and the stack will reorder as necessary. When a card leaves the stack, it just says I'm out, and then it will again reorder as necessary. So you don't really have to like manually move cards around. It will just manually like programmatically set the positions of all the cards in the list, and all you're doing is either joining it, adding it, or reordering yourself. That's kind of it. That's my idea. Lou says that's where the previous and next references come in hand. Only 3 changes. Yeah, need to be made rather than shifting all the other elements. I appreciate that, but the thing is that updating the previous and next references has to be done at the right time. Otherwise, when you update the reference, for example, by dragging a card out, then the cards underneath will either have an incorrect reference or will be up. Like, you have to update them at the right time, because if you drag a card out and move up the rest of the cards, these cards will think that this card is still there unless you update their reference after you drag the card out. But if these cards are already updated, how are you going to do it? You know what I mean? Like, the order of updating the neighbors can cause problems, and that's basically where I was running into it before. Lucretius, how's it going? Still working on sorting lists. Like, I definitely think that the previous and next references could work, but I feel like this is a fundamentally easier to comprehend solution, because all the code does is in terms of cards is basically just add them to the stack, remove them from the stack, or reorder them, and the stack handles sorting. So you drag a card in, it sorts. You drag a card out, it sorts. You drag a card to another position, it sorts. So you don't really have to worry too much about like updating the references yourself. Like, the stack should handle it. I feel like that's the goal, is to basically just make it really simple and easy, rather than having a previous and next reference that you have to update manually and then move the rest of the stack using those references, because if the references are updated at the wrong time, then it doesn't really work that well, I think. Okay, so there should be no stack, I think, for cards. We're not going to do this anymore. Blue Peabody says, gotcha, I use that strat for objects in a database, so timing wasn't an issue, as all updates are transacted in one event, so timing is the issue here. Yeah, I think timing is the issue. By putting everything in the stack and then having the stack update, I can ensure that basically we know what the neighbors are before we even start, ideally. And the neighbors are inherently sorted because they're in a list. They're in a slice, rather. Whereas before, it's like, oh, well, you have neighbors that are sorted or that are controlled by references. And, how do you deal with infinite references? Where it's like, oh, you updated the neighbors at the wrong time, so now card A's below is card B, card B's below is card A, because card A and B were dragged onto the same position, or they were moved at different times, or whatever. Now, instead, you don't really have that problem. You have a single slice and an inherently ordered sequence of cards, and there's no way to have an infinite loop, because card A's neighbor is card B, whose neighbor is card A. Like, that's nonsensical, because we have an ordered list. I feel like this would be a better solution. I couldn't get it to work before, though. So here's what we're going to do. We will create a stack. We will only... A card will not have a stack until it detects it's next to a neighbor. Then it will create a stack, and all neighbors share the same stack. Sensible. Okay. I think that's a logical play. do this. We need cards, all the cards at, we don't really need the cards. I guess we could use cards above and below. I guess that's not too much slower, so that's fine. We'll say neighbors is grid.cards above. And then we will also append the cards below. And this also removes the, this doesn't include the calling card. Okay. All right, so now we will say, let's see what neighbors we got. Okay, so the moving card says I found one neighbor. And this moving card says I found one neighbor. Okay. So now what we will say, or what we will do, Lou Peabody says, yeah, it makes sense since the card position implies its order via Y positioning and indentation, so you can infer how things are ordered that way. Very interesting. Yeah, I feel like that's the ideal, because that way you don't really have to worry too much about moving other cards. The stack will move all the cards, and it will be based on the order of the cards in the stack. The first card in the stack will be the base, like, top, and then all the other cards move according to that. That way it doesn't really matter. It's an easier conceptually, and hopefully it should be easier code-wise, because we don't have to move other cards. We just have to move all the cards. Yeah, let's see. Alright, so we want to... No, let me think. Because when lock position is called basically when a card is moved into a spot. So we want to basically either set our stack to be the neighbor's stack, or set all the neighbors to be our stack. Lucretia says, I'm going to port MasterPlan to Godot. Yeah, give it a shot. Feel free to see if you can. I'm sure that Godot could do it. It's just a matter of range. We want to share the stack, so it doesn't really matter. I mean, I guess we can make a new stack every time we drag a new card in. That seems wasteful, though. So let's try to at least see if we can. So let's do it this way. If task.stack is not equal to nil, then I guess this will be neighbor actually. If neighbor.stack is not equal to nil, neighbor.stack is not equal to nil, then card.stack is equal to neighbor.stack. We're good. Otherwise, we want to create a new stack. Or actually, if the length of neighbors is equal to 0, then we want to not have a stack to make things a little bit simpler. Otherwise, we want to either use the neighbor stack, and if card.stack is still equal to nil, then we want to make a new stack. And we want to make the neighbors share. Alright, that's complicated, but I think that's the logic we really want. Lucretia says, what license did you choose for MasterPlan and why? I chose basically just like a commercial-friendly license because I sell it. So I'm just like, okay, well, it seems logical to, you know, be like, well, I still own the code because I'm selling the product. It feels weird to sell an open source product that other people put code in, you know, under an MIT license or under some other license where it's freely available, but I'm getting the money for it. Like, I don't really care for that idea. I'm not like hard for any idea, and I do appreciate open source software, but I wanted the source code to be available for people to look at or build if they are frugal / you know, just don't have the money Or if they want to contribute code, that's fine, but I still wanted to own the code because I'm selling the product. It seemed like it would feel a little weird for the product to be open source and then me to just be making money off of it. And then also, like, someone else could just do the same thing. They could be like, well, this is MIT, so MIT sourced, open source, so I can just sell it on my own itch page, or I can sell it on Steam myself. And it's like, I don't really have a leg to stand on because it's open source, and you can do that. So I don't know. I'm like, just for licensing, for legal purposes, I'm like, it seems like it would be a good idea to kind of do something about that. I don't know. All right, so this card does not have a stack. This card does not have a stack. We move it here. This card has a stack now. This card also has a stack now. So I assume that it's the same stack. Can we? You know what? Yeah, that's fine. We will make something to make this a little easier. We will call. Whoops. We will do this and basically say return str. We will do something like this, str plus equal that, and then we say for c in range stack dot cards str plus equals c dot id I2a. Oops. All right. So this this will make it a little easier because we will be able to see kind of the order of stuff. Is it? It's not like that, right? No, it's. Yeah, no, that's it. Okay. I guess we have to call toString. I thought that was an automatic function, but maybe not. I guess we'll just stack. All right, so we're good. We're good so far. So when we go to card, so we got this. So they should be sharing a card, or sharing a stack rather. So that's good. And then we say basically if after all this card stack is not equal to nil, then we wish to add our card into the stack. And I guess we'll say for c in range stack dot cards, if c dot is equal to card, then we want to return. Okay. And then remove is going to be the same. Well, different, but yeah, we say okay, if c is equal to the card, then stack dot cards equals append stack dot cards up to I, stack dot cards I plus 1. And then we can also return after that. Okay. All right, so this is a good start, I think. So this is 0, 1, and 2. Oh. All right. So 1. Hold on. Okay, neighbor dot add. All right, that. Oh wait, no, that won't work, will it? Because if we add, just as a basic example. No, wait, that will work. Yeah, that'll work. That'll work. Okay. I believe. All right. wait, can we stack? Can we add a space? Thank you. All right, so I think we're kind of on the right track. Let's see. So there's no stack, no stack. We move it here. Now we have 0 and 1. If we move it here, it's still 0 and 1. So, and then this is 0, 1, 2, 0, 1, 2, 0, 1, 2, 3. Cool. So now here's the thing. To make this, yeah, this I think this is fine. What we want to do is basically call at some point stack update that basically, or I guess reorder, that basically would reorder the cards. Well, actually, we probably want to call it here stack that reorder, where we reorder the cards according to their vertical position. So we just call stack.cards, or rather sort.slice stack.cards, and we want to use as the function stack.cards i.rect.y is less than rect.y. Okay. Oh, I need to return. And I think we want to, yeah, something like that. Something like that. That's the general idea. Now, actually, let's do this. We'll call this update order, and then we'll call this next one reposition. So after updating, we don't have to reorder after updating. We have to reorder when we drag a card. Basically, where do we want to do this? Well, we would do this here. Let's just see if this is working first. All right, so we have 0, right? This is 0. This is 1. Did I? Yeah, 2, 3. Okay. Okay, yeah, that's not working. Because the neighbor isn't updated. No way, that's not impossible, right? Okay, so I think we need to... Alright, here's what we're going to do. This is, I think, the core idea is pretty solid here. But we want to basically look in... We want to look above and below. Yeah, I guess we'll just do it like this. Excuse me. Or wait. This is where the update stack part should probably be in a different thing. So let's do that. Let's go back and kind of rethink this. So we still want update stacks. We could just say basically if page.update stacks. Then we loop through all the cards. And we say card.update stack. Okay. All right. So we can delete all this here. Update stacks is true. So then we call update stack later on. Grid is card. Grid. We're putting the card. No, wait. We want to put this here. No. Yes. Okay. Okay. So that's right. We don't need this. Or no, we're good. So we're updating the stack. We're getting all the cards above. So now we only have to check in one direction because we know that all the grid is set. Yeah. So in this case, we're gonna. It doesn't really matter, but it doesn't really matter. But let's do it the other way. Let's do cards below. Or cards below. For below. Cards below. Okay. So we're looping through all the cards below, and then while we still have cards to search, we will append like that. The rest of below, or rather, the rest of it. But the problem is this could be an infinite loop. Oh man, this is insidious. It's such a simple problem, and yet it's so hard. Because we can't just check cards that are below, we also... No, I guess this... Alright, here's what we're gonna do. We are going to do it this way. We're going to select a rectangle, which is going to be an SDL frect. It will be card.x, card.y, card.width, card.height. Oh, rect. Yeah. But here's the thing. We want to check not just the area directly above or below, but also like inside of a card, because you could have a big card, right? Like an image or something, or a note that's in a stack, and you could put a card in there. So we can't just check above and below. We have to check basically a border around the card. We don't really need to check left and right, but we do need to check above the card by a grid amount, and also below the card by a grid amount. Times 2. Okay. Geek Hunger says, why would it be an infinite loop? If you have 10 cards in a stack of loop down from the 3rd, your loop will terminate at the 10th. It's all good. Nope, because it's possible... Wait. You are correct. it could be an infinite loop if the cards were not updated at the right time. But you're right. You're right. This is after the cards have been updated, because if you update the card, if you update the neighbors of the card in the card's update loop, then it's going to go like, you know, A, B, C, D. Well, if you move B below C, now B updates below C, but you moved it before, you know what I mean? Like if you're updating your objects this is an update kind of problem. If you're updating your objects from top down like this, right? A, B, C, D, E, but you move B below C, C's up neighbor will be B, but B is now below C, and if you update the neighbor then, you know, let's say it was below C. If you update the neighbor then B's above will be C, C's above will be B, and that will be an infinite loop. That won't happen here because we are doing this after we place the objects. After lock position is called, we update the stacks after every... Krunifis says, I don't understand the loop. You are iterating over the slice below and appending items to below again, but nothing removes the item from slice below again, so length below will always be 0. I'm still working on it. Yeah, I haven't finished this. I'm still... I'm not lost in the sauce, but I'm taking a dip. I'm taking a dip, but I'm not lost in the sausages yet. I haven't finished this. I think you're right, Geek Hunger. I think you're correct that I probably don't have to do this. I can just check below, but that still won't work because of the way that the cards below function works. Yeah, let's see. So let's do it like this, because cards below checks just like literally directly below, when really we need like, let's make a function, because I don't even use these functions for anything, I think, outside of this stack code. So I'm gonna make a function specifically for this role, which is basically going to just tell me like cards in stack area. It's going to be a little bit above grid size and a little bit below the grid size. There we go. And we are just getting not the card. Okay. Eboat right says, hello, I'm back. Hello, welcome. All right, so here's where we're working with. Whoops. Here's what we're working with right now. So we want to know if we can do something like this. Card.grid. Just move the below card and then call to update. I wish it was that simple. It was not. You can't just move the card below and then update it, because I mean the card is in itself in its own update. Like the card will update after you move. If you have card A, B, and C, you move card D into card, basically in between A and B. You will update B and C to move down, but in their update loops, they will themselves see card C move down. You see, because you move a card in, you move the cards down, but these cards are still looking to see like, oh, did a card move into my space? From their perspective, card B moved down, or I guess from card C's perspective, card B moved down into a space. When really, card D moved into card B space. You moved card B and C down manually, but sees card B moved down, and it's like, well, I moved every card together, but because the collision, the backing, like where is a card system updates later, you can't just update everything at the same time. At some point you have to decentralize the update process from the like where is my neighbor's process, and that's what we're doing here. We're basically making a decentralized stack where we put cards in, and then it will automatically sort them. And the card stack doesn't do that. Like the card doesn't have to do that, or one card does it because it is the owner of the stack. We have to get to that stage, but it should be relatively simple once it works. And we're getting there. So here we're gonna call cards in stack area. And then say while, so this is really just neighbors. For length neighbors is greater than 0. For C and range neighbors. So I guess we could just call update stack. When is this being called? At the end of the update. Okay. So we need to know which neighbors have been added already. So we will have to make another thing for that. Added. Something like this. And we can always like refine this later. It's not so much important that it's perfect, it's just important that it works. C. Neighbors. Or C. Let's see. Okay, so for C and range neighbors, we say if added map C not added, then we can do this. Or rather, new neighbors. C for in range new neighbors. If we haven't added the new neighbor, then we can go ahead. Wait. Yeah, why am I'm that's the whole point of this. This is a recursive loop. That's the point. Okay. So for each neighbor in our neighbors list or slice, we append C now hold on. I'm getting a little lost in the sauce. So we have a list of neighbors of a card. We wish to add that to the neighbors list, or we want to add its neighbors to the neighbors list if those neighbors have not been added. Okay. Because we have to look through to see if each neighbor in the neighbors hold on. I'm now I'm lost in the sauce. Hold on. So for each neighbor in the neighbors slice, we wish to add them to a slice. But we want to, and the reason why I'm doing this is because we don't want to do this individual. Crinifus says, doesn't every card just have two neighbors, one above and one below? Yeah, that's correct. I mean, that it could be just one above and one below, but I'm not. It doesn't really matter whether it's just one or multiples, because you could have multiples added on the same frame, and it just should just sort it. It doesn't really, you know, whether you have one above and one below and add them individually, or put them together into a slice, it's the same. It's the same code, because they're both neighbors. They're both adding to the neighbors stack. So the problem here. We have a card, and we want to see basically, is it in a situation like this? Is B, or if we're, you know, if we just moved B into this space, it should be able to tell, like, oh, I have a neighbor above and I have a neighbor below. And we want to basically have all of these share the same stack. They should all be in the same stack. Now the problem is we can't just go ahead and be like, okay, well, I just moved B here, just share like A or C stack, because depending on when they update, one of these could be left out, or some of these could be left out. For example, if B says, oh, A has a stack, I'll share A stack. If C already updated for whatever reason, it wouldn't have its stack. Or if D was just moved, it wouldn't have its stack. So that's this. We need to share a stack. Geek Hunger says, I think you make it way too complicated when I have a global stack that controls the update cycle. Well, the problem with having a global stack, and I don't know what you mean by global stack, because the stack is local to each set of cards. Like, you know, you can have multiple stacks on a board. You can have 5 stacks on a board, 10 stacks on a board, depending on, you know, just where the cards are positioned. Yeah, I don't know what you mean. Like, how instead you provoke recursive loops by having cards themselves have control over updates. I'm not sure what you mean by having a global stack, because I would, if I could, make stacks like cards. What do you mean? Like, we have to have multiple stacks. Make stacks like cards, multiple stacks. I'm trying to envision how this would work. I mean, I understand that's what I'm trying to do here, is make multiple stacks. They're just basically the cards determine which stack they're in, or detection of these stacks. But if we were to make a global object, a global, you know, do this globally from the page, from the board, and we just had a list of cards like we do, but then also we had a list of stacks. Each stack manages a set of cards, and there may be multiple stacks, but the card doesn't have to maintain the order. Yeah, I mean, like, whether, like, what we're doing is basically determining which stack. Basically, the card needs to know where it is, and determine, like, oh, I'm next to A, or in this example, I'm joining the stack of C and D, but A is also here. I should include him. That's B's job. We can't leave it to A, because this code only gets called on cards that are moved, because we don't want every card working on this. Lucretia says, how long was my streaming? I was just planning to do a couple hours, but I'm probably gonna stream until I either die of like mind flood, or until I get this solved. Geek Hunter says, if another card gets added to that stack, then add the card to the reference. Add the card. If no stack exists, add one and assign the card. That's what I tried to do. The problem is, if you have a situation like this, or I guess a situation like A, B, and C are, right? A situation like this, C and D are together. Let's say they already have a stack. B's here. He joins C and D's stack. There's no problem. He has to also assign A a stack to the same stack. Otherwise, A won't be there. B, C, and D will have a stack, but A won't, despite the fact he's there already. That's not a problem either. We can assign the direct neighbors to our stack after we find our own stack. The problem comes in when A has a neighbor above it. We have to assign all of them. We have to get all of the cards in a vertical stack and assign them to the same object. Like, we can't just get the neighbors. We have to get the neighbors of the neighbors recursively. We can't leave it up. If we did this globally, where we... I don't even know how you would... Can I do this globally in some way? So, because we have the backing the backing data. So we have a vertical list. Like, we already know that the cards are there. We already, or at least we already can tell. So I guess what we would do is just like I'm trying to think about how I could do this, but it seems like at its core, whether we do this globally or not, it's the same thing. We still need to loop through and grab each neighbor, basically. I think I'm overthinking it. Lucretia says, it'd be cool if you joined some game jams and then played the games on stream or something. Yeah. Yeah, I could see you doing that. That'd be fun. I'm not very good at game jams, I think. I think I need to, like, I don't have the time to, like, spend a week or even 3 days, like a weekend. I have things I need to do, unfortunately, so I can't just be like jamming for 72 hours. I could do like a jam of my own, like, volition, but every jam is always usually like on Friday through Sunday or something like that, or a week where it's just like I wouldn't be able to spare a certain amount of time. But I guess I could give it a shot. I guess, you know, a lot of people can't spare time and they still manage to get stuff done. Geek Hunger says, I mean an object that has an array of stacks, have an array of cards, both independent. That's what I'm doing. It's just the stack is in the card. Like the stacks are independent of the card. They're just, the cards are what determines whether they're in the stack or not. I mean, moving this code outside of a card into something else, it doesn't really solve the problem. Like, we still need to do this process. We still need to add all of the neighbors to a stack. The stack is stored on the card, but the stack is not the card stack, if that makes any sense. Like, it's shared. If we were to move this to another, like a global object or something else, it would be the same code. Like, we would still have to do the same thing. Okay, so we have neighbors. We have basically the neighbors of B, A and C. What we also want to do is say not just those neighbors, but also the neighbors repeatedly of B, which are A and C, but also A and C's neighbors, which are B and D. We don't need B because we are B, but we also want D. So we want to say for each neighbor, get the new neighbors, and for each new neighbor, we wish to, or maybe let me just try doing it like this. This isn't that hard of a problem. I just, for some reason, can't wrap my mind around it, despite the fact that I've done this before, probably for this exact program for MasterPlan, in addition to other things. So basically, we loop through, we add the neighbors. Okay, that's what it is. New neighbors, and then we want to remove okay, I think that's what I need to do. So we say basically for in range to check 0 dot, or I guess grid dot cards in stack area. Okay. All right. So this should basically give us everything, and then we just basically say if we don't want to do it if it's already been added. So if added map in not added, then we want to do this, and then also also, all right, I guess we have to, yeah, added map. Okay, and then so we're looping through, we're grabbing each, yeah, okay, and then we just say, so this should at least do kind of what we're looking for, I believe. Okay, it's infinite looping. Wait, doesn't this 2check equals 2check 1? Doesn't that take out? Doesn't that like lessen it? But the stack itself controls the update of all its children, and you can loop over it and assign sorting. While you now have the problem of not knowing the state of the cards of when or what they do. The stack itself controls the update of all its children. The stack does not control the update of all its children. I do not do that, and I do not wish to do that. The stack is independent of the stack. I think I see what you mean. I think it's just a difference of approach. 2check is greater than 0. Okay, 2check 1 from 1. This should be cutting it out, like cutting out the first value, right? So this shouldn't. Isn't this? Am I wrong? Is this specific statement I'm saying, is this wrong? Is that an Electron app on your taskbar? Yes, this is, for some reason, VS Code comes up as this little electron symbol instead. Line 738, you added in before you remove it. But my bad, you're right. There we go, okay, that's where I'm missing. Alright, yes. Perfect, okay, cool. So now, 2check 0 this is what we're looking for. So we basically just want to say, so this should give us all of the neighbors. I guess we could just do it this way. Well, no, 2check, yeah, this is all the neighbors at this point. Yes. Yes. I guess actually we could just see if... No, yeah. I think this... I'm trying to see if this would... Yeah, I guess this would give us all the neighbors. Okay. So what we want to do now... Because this is essentially, we're popping from the list. So we grab each neighbor and we want to see if it has a stack, and if not, create a stack. So I guess we can just make a function for that. How do I want to do this? Let's do it like this. I think this is over. I'm doing the same thing like over again, but I want to just have a static list before I do anything else. So this is 2check. Okay, so neighbors equals append neighbors 2check 0. And again, I can fix this later. I can like simplify it and everything later. This is fine for now. Okay. Now we say for in range neighbors existing stack in that stack back to nil. Existing stack equals in that stack. Else and then this. All right. Okay. That's complicated. it's kind of complicated, but hopefully it should work. When is update stack? There we go. Okay. All right. So now, let's see. Let's check it. Okay. So what we'll do is just say if card, or rather, if length neighbors is equal to 0, then we just say card.stack is nil and return. Okay. So this is 0, this is 1. Let's see. Select position, we update stack. Update stack is called later. Then we add the stack if it has not been added, and then oh, I see. Let's call update order. Let's do it like this. Let's not call update order and add or remove. That will make us manually call it. Yeah. All right. Cool. So now we go back to card. We call card.stack update order, because this is after dropping it. Yeah, I believe. Yeah. Okay. All right. So card.stack. All right. So here's 0. Here's 0, 1, 2. Okay. So 0, 2, 1. We move 0 down. Now it's 2, 1, 0. We move 1 up. Now it's 1, 2, 0. All right. So this is working. They don't have to be linked right now. They don't have to be, yeah, okay. If card stack, so here's the thing. We want to only assign the stack later. Let's see. Neighbors 0, then we say stack nil. So let me think about this. We do not want to do this like that. If the length of neighbors is greater than 0, then we basically say, okay, we have to make a new stack for ourselves or add a stack or whatever. If the length of neighbors is 0, then instead we remove ourselves from the stack. And we can say, I don't have a stack. All right. Let's see. All right, so this is 0, this is 1. All right, so 0 and 1, 1 and 0, 0 and 1, nil and nil. Okay. 0 and 1, 2, 3. So if we remove 3, oh, this is being called on each one. Okay. So let's print out card.id so we can kind of see this a little better. All right, 0, 1 and 2. Okay, 0, 1 and 2. Why is this being called in different orders? Like it's not consistent. Unless 210, 102, 021. Maybe I moved it. All right, 120. Okay. All right, we're good. So 120, 012, 10, 2 is nil. All right, I think we're getting there. I think this is basically working. So 2, 3, and 4 have their own stack, whereas 0 and 1 have theirs. If we rearrange this, now it's 3, 4, 2, 4, 2, 3, 0, 1, 4, 2. Okay. Oh, I see. If the stack is not equal to nil. If stack is not equal to... Oh, here's a... This is a little different. Okay. So, if the existing stack is not equal to nil. Okay. If card.stack is not equal to existing stack, then card end stack is not equal to nil. Stack.remove card. Okay. If existing stack is not equal to nil. I think this is actually complicated. Like I'm overcomplicating this specific logic, because basically we want to remove the card if we're gonna assign. Hold on. I think the general problem is not of sorting, but the entire concept of neighbors. Neighbors should be conducted from the sorting. Stacks come from object position. Yeah, that's what I'm doing. Like neighbors, I'm not defining neighbors here. I'm using this just to name the variable. But neighbors, Bakadayo says, "What's up? How's it going? Hello." Neighbors is how we know which stack cards belong to. So like this is a stack because of their positioning toward each other. Neighbors aren't kept around or held anywhere for information. That's how I used to do it until I wanted to do it like this, where basically a stack is just a list of cards. It's just a slice of cards. That's the core concept. But in order to get to this stage where cards are in this stack, we have to know which stack do we add them to. You know, if I have this card and I move it here, we have to make a stack out of 0 and 1. So how does 0 know, or 1 know that, or anything know that these two cards are next to each other? We have to see what are their neighbors. That's what this is. So I think the right way to do this, for in and range neighbors, if in.stack is not equal to nil, existing stack is equal to in.stack. Okay, if the length of neighbors is greater than 0, we can just move this in here. If length of neighbors is greater than 0, try to get the existing stack. If it's not equal to nil, then this is what we're going to assign. We could probably put this down here and then say if card.stack is not equal to nil, card.stack.remove card. Okay. Alright. Card.stack is equal to new stack. Existing stack. New stack. I guess actually this might be better to like make a function to assign the stack. That we can kind of simplify this. Let's see. All right. Quinifis is maybe a function that merges the stacks of all neighbors. I don't think that's, what does this do? This reorders, yeah. Update order. I don't think that's necessary. Merges the stacks of all neighbors. Yeah, I kind of see what Geekburger was talking about. Geek Hunger rather was talking about. When it comes to reposition, like creating stacks outside of the card, but at the same time, it still would be roughly this. If their neighbors, they are all the same stack. Yes. Yeah. Let me work my way through this first. Let's see. Say you have card A and B. B goes into stack of A, who is now dropping his stack. B adopts card A stack. It doesn't really matter who drops the stack because you just share the stack. If you're moving into another, if 0 is moving into card 1 stack, it takes one's neighbor. It takes 1 stack. Why? That's just the way it is. I don't know. like if this goes here, they share the stack. It doesn't really matter which. I guess that's where our minds are diverging. You're like, how do you determine that 0 adopts 1 stack as opposed to 1 adopts 0 stack? My mind is, it doesn't matter whose stack it adopts because all the neighbors are on the same stack. We don't have to worry about which stack to adopt because they all use the same stack. That's the problem. Like that's the reason why it works, but that's also inefficient, and it's not the best because it probably would be best to just not even have this question. That's why this code is complicated. So I probably will go back and refactor it to maybe be simpler, but that's why it works, is because it doesn't matter who drops a stack because we're making everybody share 1 stack. As long as there's 1 stack, everyone's on it. If there isn't a stack, we create it and then everyone's on it. That's the difference. And then we just say card.set stack. All right, that's simpler. That's simpler. I think that is simpler. Let's see. Zero, 1, 2. Okay, so 1 and 2 are together. Now it's 2 and 1. Now it's 0, 2, 1. Now it's 2, 1 and 2. Now it's 0 and 2 and 1 is nothing. Yeah, that's true. How do you sort them currently? Sorted by vertical position. I call update order whenever a card's stack is set. So I guess this is indicating basically a card's. I guess we could do it this way actually. If card.stack, not even just stack. Then we set it. Yeah, we call update order. That basically updates the order according to the Y position. So my way now that now that I'm thinking about it, it is inefficient because, or at least it seems like it is inefficient because we're basically like, there is no central authority. Yeah, there is no central authority for. Oh, hold on. Two says it's part of 302, but what about 1? 1 says it's part of 2 and 1. So there is something going on here. 0 isn't bridging the gap. Wait, hold on. This might be an issue with the neighbor code. Cards in stack area. X, Y minus the blue sky. Yeah, that should be correct. Select. Cards do not seem to handle stack switching correctly. Yeah. Seems like maybe this isn't the right way to do it. How else could we do it? How could I implement what Geek is mentioning? Geek Hunger is mentioning. Maybe neighbor calculates off of the top right corner. No, it's calculating as far as I can tell from the correct area. It's basically calculating like this. Should be calculating like this. So a normal card, for a normal card, it calculates one cell above and one cell below. This is a little bit bigger, so it should calculate one cell above and one cell below the bottom, like that. That works. This works. So 0 says it's part of... Yeah, why does it say 03021? This might be an issue with... Oh. Here we go. It should be, I think... Is this it? Grid.cards in stack area. 2 check 0. Because we're pulling... Yeah, that should be correct. I forgot the order I created them in. Okay, so we have 0, 1, and 2. Hold up. Yeah, why are they not in... Why is there no list? No stack information. The stacks are empty. For length to check, it was working fine. That's weird. To check length to check 0. Okay, so to check 0. Okay, I think it must have been like this area. Oh, okay, this is probably it. There we go. Okay, let's see. 0, 1, 2, 3, 4. Okay. Yeah, these are still empty. A stack is not equal to stack cycles. Maybe, you know what? Maybe this is not what we want to do. Let's do that. Let's leave it the way it was, at least for now. All right, 0, 1, 2, 3. Okay. 3, 0, 1, 2, 0, 1, 2, 3, 1 and yep. Why does it think it's 1, 0, 2, 3? Because it's the same stack. Wait, no. Oh, because they share a stack. Oh, so this stack still exists despite the... Oh, that's crazy. So the stack is no longer... It should be 2 stacks, but it doesn't work because this... Like, this is a stack, right? We move this one out, but because... their neighbors are still there, the stack's still there. That's the problem I ran into last time. Okay. All right, here we go. Now we're getting down to why this isn't working. So basically, because these, where's my A sprite? Because these A, B, C, and D were in a stack, we move, for example, C out of the way, or in this example, A, B, C, and D are in a stack. We move C to touch D, so there no longer is a single contiguous line between A and C. Now it's at the bottom, but the stack still existed, and so it's like, okay, well, A and B still have their stacks, D and C still have their stacks, but these should be 2 different stacks because they're no longer contiguous. Okay, so what we'll do is do what Geek Hunger advised. I think what I'm gonna do is just loop through every card, see if there's a card above it, and if not, it will make the stack. So that all right, you know, we can make a stack for it. So for example, in this example, 1 and 2 will be the stack heads. No. The problem that I have, or that I'm trying to get behind, is basically if we were to decentralize the stacks, how do we know which stack a card belongs to? We can't make the first element the head necessarily, because the head, there shouldn't be a head. There should just be a slice of cards. When a card moves, stack must split into above and below and remove itself from both stacks. Then when placed, it joins the stack of its neighbor. That's overly complicated, I believe. Card needs to loop stacks and see where it fits. I think I gotta think about it some more. Unfortunately, I've been grinding on this for like an hour, and I'm not really that much closer. I'm actually further than I was when I started, in terms of like actual progress of the feature. Like, this has all been very useful. Exploratory coding, or coding to try to resolve a problem, is necessary. But I gotta think about it some more, because fundamentally what we want to do is have decentralized stacks. That would be good, because then we could just be like, we can make a function or an object that we could just say, like, you know, hey object, you know, what stack am I in? And it gives you the stack, and you add yourself to the stack. It shouldn't be something that's on the card, but how we actually implement this, or it doesn't need to be something that's on the card, but how we actually implement this so that multiple cards can share a stack, and when they move, it can just be like, am I still in the stack? No, let me remove myself. How we actually do that is where we have to get into kind of spatial stuff. Okay, let's do it. Let's just do it. Let's just do it. We're gonna make a stack manager. Actually, I guess we can just put this in stack. I don't want to make a new thing. This will be stack manager, which is a struct. And the job of the stack manager is to tell a card. Oops. The job of the stack manager will be to tell a card which stack it belongs to. And if not, it will return a new stack. Ziotic says hello. Hello. Welcome to the stream. I'm about to close down. I'm about to end. I've already been going for a few hours. But here's the idea. We're going to assume that it's not possible to have stacks overlap, just for simplicity. We're not gonna have, there's no, I don't think, necessity to have stacks like this, where it's just like, oh yeah, you have, 3 stacks that are literally on top of each other. We're going to assume that this is a stack, these are 2 stacks, this is 1 stack, this is 1 stack. If we do this, it should basically mix them all together and make a single stack. So we don't have to worry about that. So what we're gonna do is we're gonna say that a stack basically has bounds. It goes from one point, the top left point of the first card up here, to the bottom right point of the last card down here in this example, or here and here, or in a single card here and here. So when you call, basically get stack from the stack manager, it loops through the stacks to see, well, if there is no stack, it'll just give you a new stack, and you'll add yourself to the card, to the stack, and then the stack will have the bounds of this. When you add a new card, it will say, do I have a stack? There is no stack. Do I have a stack here? Yes, there is an existing stack there. Okay, I'll add myself to that stack instead, and now the new bounds will be this. All right, I think I'm getting it. It took an hour, but I'm finally getting it, and thank you for the advice, Geek Hunger. I might have still been like, maybe I can make my own way work. Maybe the original way would be a good idea, and I don't think that was wise. I don't think that would be wise, rather. So when we do this, we want to basically get the top left and bottom right corners in grid positions of these stacks. So that would be the first and the last card, and the top left and the bottom right point. So stack dot cards 0. So this would be top left. Dot page dot grid. Okay, so this is gonna be grid dot select okay. You know what? Let me do it this way. Hold on. You're welcome, and you're doing a great job. Thank you. I'm trying, man. It's hard. It's like I'm dying internally, but I'm getting there. Let me just. Okay, so cards. All right, so this is a basic application, a basic function. Card. Do we use this somewhere? Yeah, we're not gonna use this anymore. All of this can go, I believe. All right, so the bounds is going to be basically the card. Wait, why don't I? hold on. Grid.select. Okay. Okay. So we're going to select the stacks top left, and then the bottom right. Now the bottom right is going to be, I guess it should be this, right? Direct.y plus, I'm just gonna bottom direct dot, oh, whoops, this should be x. Okay. So this is the selection. I guess we'll just return this. Alright, so this is basically the selection, I guess this would be selection. A selection of the grid that features the area of the stack. So basically we can use this to determine what cards are in the stack, I believe. Now, let's see, this is the X and Y, the width and height. Yeah, this isn't gonna work. We need to, let's do this in new. We'll do this actually just like raw, this. We will return a new grid selection. That is the stack, or I guess we'll just say top.rect. Okay, okay, so we got the top, we got the bottom, so this is gonna be the bottom rect x plus bottom rect w, bottom rect y, bottom rect. Okay, so that should work. Let's actually do it like this. We will select it from direct. Nah. Excellence. Let's do it that way. That would be better. That's better. Okay, that's better. That's better. All right, so we want top rect x, top rect y, top or bottom rect x plus bottom rect w, y plus bottom rect h. Okay, this is what we needed, I believe. All right, now we can say with the stack manager, if given an X and Y position, or I guess given a rect, it should give you back a stack. Existing stacks, it should be something like this. It should be probably something else, but I guess this is fine. Basically, we say for stack in range, stack manager stacks, stack dot selection. Can I please rename this? I don't like stack dot selection. area. All right, so if stack dot area selection dot contains rect, return stack. Otherwise, return new stack, and new stack is going to be new stack. All right. Okay. Selection contains rect. Cool. Okay. Selection.grid.lock. Lock rect. You know what? Never mind. Wait, there's an error here? What? Oh. This is actually just like the grid position. I can't fix that. Never mind. Okay, locked X, locked Y, locked W, locked H. Return selection start X to selection dot start X and all right. Locked x2 is less than or equal to selection.end x, and locked y2 is less than or equal to selection.end y. Okay. Then contains rect, return stack, otherwise return a new stack, and I guess we should add it, huh? Stack manager stacks is a pinned new stack. All right. So now we need to make a global stack manager, which we can do. Well, it doesn't have to be global, but it has to be in the page, I guess. Update stacks. Let's move down. Manager, stack manager. Stack manager. All right. This doesn't solve all of our problems, but I think this should definitely get us closer. So when we call update stack, we don't actually have to call update stack, I suppose. Let me think. All right, let's just say we do. So card dot stack manager dot get stack. We call the rectangle we have. And then we just set Geek Hunger gave me €5 and says keep it up. Thank you. I'm dying, but I appreciate that. Really do appreciate that. Oh my gosh. Let's see. So we have the stack. We're getting the stack. We're setting the stack. Do we have to update? No. Okay, so we can remove. This is a good start. This is a good start. Don Duvall says, "Are you just tired, or are you actually feeling ill or something?" Hopefully, just tired. Oh yeah, I'm tired. I've been grinding on this for like 4 hours. I started at 9, dude. It's almost 4 hours. I've been like thinking about this Well, working in general, but then I've been thinking about this specific issue for like 2 hours. Normally I get up and walk around and like, you know, come back to it later if I need to, but in a stream it has to be, you know, focused. You gotta sit and work. You can't like get up and take a break really. I guess I could. Might be time for a lunch break, yeah. Might be time for a lunch break indeed. But I can get through this. Alright, so we're getting the stack. We're setting the stack. Don Duval says, I will be here when you get it. Thank you. Thank you very much. Okay, so this might be working. At least it's not crashing. Let's see if we are getting a stack. Alright. Okay. So these are 2 different stacks. So I think the issue here is because we need to yeah, the rectangle we're getting here is not enough. The stack it needs to look a little bit further. Me mistakes is we are with you. Thank you everybody. The power of everybody is giving me energy, much like every shonen anime created since the dawn of time. I think that should work. Wait, get stack. No, we can't do this. We're passing in the rectangle directly. We can do this, but we just have to make a copy of the rectangle. Right, okay. Alright, that might be it. Just try Godot with nim binding. Works quite well, but not much documentation. Oh yeah, I'm not sure about the bindings for like Godot. It's a cool idea, but yeah, I'm not sure. Lou Peabody says, are these changes going to be in the GitHub repo after the stream? I'm really curious about this issue. Want to check the code? Sure. Yeah, I'll see if I can upload it up there. Okay, I think the issue here, let's see, stack area selection contains. Okay, I guess it's possible that stack is equal to nil, we remove it. Okay, yeah. I guess what we'll do is if a stack has no cards, we will remove it from the list. Stack manager. We'll do this. Actually, we'll do this here. We'll do something like that. We have to pass the stack manager here. Alright, and then we have to have gotta pass here, and then we have to say stack manager move stack. Manager stacks. All right. Stack manager that remove. Okay, that's part of it. Let's see. Let me just see what I just printed, because I'm a little bit lost in the sauce. Okay, so we just printed the stack. Okay, so that's the list of cards in the stack. All right. So this is 2 different stacks. Okay, so that means that this code isn't working correctly. Y is, okay, y minus equal, y, oh, plus equal. Alright, it's still not working correctly, but it might be for another reason. Let's see, locked x, locked y, locked x2, locked y2, return locked x is greater than slash master. Locked y, locked x2 is less than or equal to. Alright, let's see. Let's see, index out of range 0, width length 0. Get stack, set stack. All right, we'll just say, Well, wait, how is it possible that this... All right, there, let's just, let's stop right there. All right, so we have, where is it print? Okay, so we have the selection, or basically the in this case, the stacks. Start and end, so it's -7, -4, then 2, -3, okay, -7, -3, 2, -2, okay. Alright, -7, -4, 2, -1, -2, -2. Okay, let's see. Minus equal 1 plus equal times 2, right? Oh wait. Yeah, my bad. That's wrong. This shouldn't be modified at all. It's the stack area that should be modified. So this is supposed to be top rect x minus, or not x, y minus globals.grid size. So we'll just say GS for short. And then plus GS times 2. Or no, just plus GS, because this is the bottom right point. Yeah. Start end. Okay. I don't think that will solve it, but let's see if it does help out. Yo, let's go. Okay. So that actually, I think, does work a little bit. Let's see. So we get a stack. Let's see, we're getting the stack. Set stack. If stack is not equal to nil, then we remove it. We update the order. We don't have to do that anymore because the stack manager handles updating the order of the stacks. It can do that once per frame at the end of the frame. So this just handles removing the card from the stack or adding the card to the stack. We still haven't gotten to repositioning yet, but that's fine. Actually, let's do this. Stack manager. Yeah, okay, let's do it like this. If the length stack.cars is equal to 0, then we will skip that stack. And then also, we won't do this with the stack because the stack shouldn't remove itself from the stack manager. The stack manager should do that. So first, okay, if length stack.cars, then we remove it. Yeah, okay, so we're good with that. I think this should work. Okay. I think that. Actually, no. We need to have a removal to remove stack. Let's see. Remove. Just gonna append. Stack. Okay. There we go. And then we basically say for stack in stack manager to remove. Let's see. Okay. I think I'm on the right track here. Let's see. So we have to call update on the page. Down here, we don't call update stacks anymore. Actually, we can call updates if update stacks. We just call stack manager update here. Stack manager runs through. Okay. Oh my gosh. All right. Can we, see what's going on here? Oh, we're not calling update stack anymore. All right. All right, yeah. Let's go to, I guess we can. I guess we still need to do this. I guess we still need to do this. Okay. C Nullum says, can you make MasterPlan online, even be able to see other people's mouse positions? Yeah, I would like to. That's further down the line though. But yeah, I would definitely like to enable you to like play multiplayer with your plan. That would be good. All right, I'm dying. This isn't working. Why isn't this working? Hold on. Okay, I think I have to think a little bit more. I think I'm on the right track, but I have to think a little bit more about like how this works. Because I think I just like went back to the same problem, which is the stack size, size of the stacks isn't updated, or the stack manager. Well, the stack manager I think works the best way it could. Oh my gosh, 50 euros. Oh my god. No, man, just chill, please. I'm dying. I'm dying. Please don't give me anything else. I'm good. Just please. I'm dying. I'm so tired. I'm so tired, man. I gotta take a break. I have to. This is gonna be it. Thank you very much for stopping by my stream. That's an insane donation, Geek Hunger. I really do appreciate it. Thank you. But yeah, like you don't have to give me anything for this. This is a disaster. But I'm doing my best. I'm doing my best, and I'm gonna go off stream. I'm gonna get something to eat. I will continue working on this because this is once it works, it will be sick. You'll be able to drag your tasks into a list, and it'll just automatically like pop, into position. You'll drag it out, and it'll automatically pop into position. You can like move them around with your keyboards, and it'll automatically pop in position. It's gonna be sick, but I just need to think. I just need to think more on it and reflect on how I got to this state. There's so many. Thank you, everybody. I can't think about this anymore. I do use a mechanical keyboard. It's from Logitech. It's a good one. Don Duval is a stack of container. How about the cards being a linked list? I'll have to consider that as well. I don't know. I'm dying, but I really do appreciate everybody's encouragement and suggestions, because I mean, at the end of the day, I think this is a better system. I just need to kind of what's the word? Like, come to terms with how it all works in my mind. And then once I do that, I can, kind of work on it a little bit more and get it working. Because it's not that complicated. It's not that much stuff. It's just how it all fits together is really kind of where the problem is. How, cards inform the stack that they're added, or at what point they get added. That's kind of the hard part. But it's working really well. Or at least it has potential to work really well. And I'll have to catch you guys on the flip side next time. If you wish to support development, feel free to check out my Patreon. Feel free to check out my itch page, my Steam page for MasterPlan. I really do appreciate people sharing it on social media. But yeah, thank you. And I appreciate everything that you guys have been doing for me. Regards. Imagine if you solved it immediately when you next start streaming. Man, I wish. All right.